What is up? Daniel here again with the Virtual Robotics Studio, and this video we are going to be assembling the intake. So this is going to require a lot of parts, but not a lot of cutting and fabricating. So mostly it's just going to be assembly today. Although we will have some PVC. This is half-inch PVC that we're going to use as spacers. So we're going to be chopping this up into a bunch of small pieces. We need our rounded hex shafts. I think it's going to take 2 sticks of those, maybe 2.5. And then we need a Neo 550 motor and the pinion that's going to match that. That is a 13-tooth pinion. We're going to use the ultraplanetary gearbox, and we need the ultraplanetary half-inch hex adapter. So all that will go together to power it. We've got 6 of these Andy Mark pulleys, timing belt pulleys, and 1 little hex shaft collar. I think the bill of materials, or they're sold in packs of 5, so there's some other places you could add them if you wanted to, but we think 1 is the most important one. And then we got a couple of these gears and 15 hex bearings. Going to use a bunch of these little standoffs to help hold everything together. And then to hold everything together, we've got these 3/8 inch long. These are 1032 bolts. Button heads, I think, was on the bill of materials. But if you just have regular socket heads, that's going to work for pretty much all of the stuff we're attaching today. We'll need a few more of those washers to help retain our hex shaft. And then the most important pieces that you need for this are the side plates. So these are purchasable, I think, from pretty much every vendor. Thrifty-Bot, Rev, Andy Mark, I think they're all making them. You're going to need 4 of these to build the intake. And we strongly, strongly, strongly recommend that you buy these and don't try to make them yourself. We'll look at if we can find an easy way to make them, but you're going to have more success if you just buy them and make sure all the holes are the right size and in the right place. All right, I think that is everything we need to get started. So a quick thank you before we go to Argosy and Everybot. All right, let's get our cutting out of the way. So we've got these rounded hex shafts here, and basically those side plates are going to go on the sides of our robot, like this, and we drilled those holes to line up with these, so that's going to be easy for us to put together when the time comes. But this shaft then is going to run all the way through the plastic on one side, all the way through the plastic on the other side, and there's going to be some bearings pressed in here that are going to stick out a little bit more. So we want to make these shafts essentially the distance across here from the outside to the outside. So on mine, I'm getting 16 and 5/8 plus maybe an extra 1/16 of an inch. And we want to add 1/2 an inch to that. So instead of 16 and 5/8 plus a little bit, we are going to be 17 and 1/8 plus a 1/16 of an inch. And that is accounting for, the extra 1/2 an inch will account for the plastic on both sides and the bearings sticking out on both sides. So one more time, I'm at 16 and 5/8, and I'm going to go to 17 and 1/8 because that will add 1/2 to it. All right, and so the robot can get out of my way here. And let's mark these up. So we'll measure this out to, all right, so 17 and 1/8, and then I was like plus a 1/16 after that. So that is where I'm going to go ahead and scribe my line. Make sure that is enough that I can see it. And we'll go ahead and cut these one at a time, but we will need 3 of these that are this length. So let's get the first one cut. Okay, one's good. Let's go ahead and I'll measure from the other clean end here. And once again, it is going to be 17 and 1/8 plus 1 extra 16. So 17, Stay on there. There we go. 17 and an 1/8 plus the extra 16th is right about there. Double check. Looks good. Okay, that's 2 down. And same thing for the third one. Okay, so we have our 3 long pieces done. There's going to be one more short piece that we're going to cut, but I want to make sure it fits with your robot. So if you have different pulleys than I do, you might need to cut it to a slightly different length. So we're going to hold off on cutting that last bit. If you did get the 90-degree max gearbox, it does come with a little shaft, and both ends of that are already tapped. So you can use this. We'll end up cutting this down a little bit, but it saves you from having to tap one of the ends. So if you've got this around, we can use that as our short shaft, and then we'll just adjust it down to the right size afterwards. All right, let's clean this up and start our motor assembly. All right, I did say we were about to do the motor assembly, but before we get to that, we've got to tap the ends on all 3 of these hex shafts that we just made. So should be experts at tapping by now, since we did so much of it earlier, but we'll do one as a reminder here. So I like to get it clamped up in the vise. I've got my 1032 tap, and I've got the Tap Magic. So we're going to add some oil, cutting oil here, and on the tap. And remember, right at the beginning, the key is keep it as straight as possible going into that hole. Just be gentle, try to keep it straight. Look at it from a couple different directions to make sure you're not on any kind of big angle. And once it starts going in, it's kind of set. Okay, and we'll spin it a few times, but once it starts getting hard, remember, back it off a little bit to break the chips free. So it's forward for a bit, and if it gets hard, just back it off, or just do a little bit forward and a little bit backwards, and eventually you'll get there. And we need about the same depth that we needed last time. So last time we went down to, we need enough room sort of for our 3/8" long bolts to screw into this. And we can do a little bit extra, so maybe if you end up with 1/2" long bolts, it will still work fine. But there's no rush on this. Take your time. Remember, it's much worse if you rush and break the tap off in there. All right, and that's got to be deep enough, so let's back it out. Okay, so that is the first one done. I'm going to flip this one over, do the other side, and then I'm going to do both sides of these two, and we'll be ready for the next step. All right, let's now put together our motor and transmission. So get your Neo 550 box and the Ultra Planetary gearbox. This one comes with a whole bunch of stuff inside of it. So we definitely need the hardware pack. And we need the Ultraplanetary 550 motor plate. So that one is the first piece we're going to need along with the hardware pack. And then I think if you pull out all of the other baggies, you'll notice that at the bottom there is a motor inside of this box. So you'll see a motor that is an HD hex motor. That is not the motor we want to use. We're going to use the Neo 550, not the HD hex motor. Actually, I don't even think this is a legal motor for FRC. But it's cheaper, I think, to buy the whole kit with the motor than to just buy the parts you need. So free motor. We also don't need this hex shaft that is the output or any of these wires. And then from this other stuff, you're going to find a 5mm hex output V2. We need that. And then there are stages here. So there's a 5-to-1, a 4-to-1, and a 3-to-1 stage. We need the 5-to-1. We don't need the 3-to-1 or the 4-to-1. So I'm going to put those back in the box and close that up. And open up the Neo 550 box here. And it is a very tiny, cute little motor. OK. First step. Open up the hardware bag. And I'm going to kind of pour everything out, but be a little careful that we don't lose anything there. And actually, before we do any of that, too, we're going to grab there are these 13-tooth pinion gears. And there are 2 of them in here. We're only going to use 1, so I'm going to leave 1 in the bag. But basically, what we need to do is we need to push this onto the motor shaft. And I don't think you're going to be able to do it by hand. It is what we call a press fit. So the hole in this is smaller than that shaft is. So we got to force the 2 things together. Now, there are a lot of different tools that you can use for this. If you have an arbor press, this is kind of like the right tool for the job. We put that down there, and we can pull down on this to smash it into place. So if you've got one of those, that is the best thing to use. The second best thing to use, which is what I'm going to use, is the vise over here. And if you don't have a vise and you don't have an arbor press, if you're very careful, you can get it done with a clamp. So you'd put the clamp around the motor and then tighten the clamp to squeeze it together. But we're going to go ahead and use the vise. I'm hoping most teams have a vise that they can use. And I think if you push on this a little bit, you can kind of get it to stick there by hand, which will make the next step a little bit easier. Okay, and then we're going to open the vise up all the way until the motor fits. And I'm going to put this kind of right in the middle. I want that pinion to be right kind of in the middle of the vise. And just very gently tighten it. And we're seeing it sliding down. Just keep going. And you'll feel a change. You'll feel a change in the amount of force that it takes to move it. It'll sort of bottom out. So right there, I sort of hit the wall. That shaft is now sticking through and hitting the vise. And this is as far as it's going to go. So at this point, I'm going to back it out. And if you're ever not sure, it's OK to just back it out and check. And what we're looking for here on the output is that pinion gear should be flush with the end of the shaft that's coming out of the motor. So those are nice and flat next to each other. So that's in the right spot, and we're good to go. But if you were to take it out of the vise, and you could still see a lot of the hole in the middle of our gear not filled with the shaft, the motor shaft, then just go back and give it another little twist. The key here is just everything, the straighter you can keep everything lined up when you're squeezing it together, the better. And so you can see it'll be a little bit harder to keep everything straight if we were doing it, with the vise and stuff. Or with the C-clamp instead of the vise. All right, so that is on. Our next step then is to find the Ultraplanetary 550 motor plate. You can pop that out of the bag. And on this, there are, on one side, it's nice and smooth, flat. There's nothing special about this side. If I flip it over, this side sort of has, you can see a circle and some cutoffs on the sides here. And then these 2 big recessed holes around the slots. That's what we're looking for, is those 2 recessed holes. And from our hardware bag, we are looking for these tiny, tiny button head screws. So these are M3 button head screws. So to screw these in, you're actually going to need a metric hex key. So you need a 2 millimeter metric hex key. All right, and we're going to take this and just drop it onto the motor. You'll notice on the motor there are 4 holes, 1, 2, 3, 4, and those are all tapped holes, so we can screw this plate into any of them. And it doesn't matter which ones you want to use. So just spin that around until it's lined up on 2 of the holes. And then we're going to tighten these M3 button heads. And on the first one, I'm not going to tighten it all the way. I'm going to make sure I can get my second one started first. Okay. And when they both start getting tight, you'll notice too that you have to kind of hold the plate because the back part of the motor is what spins. So if you hold on to this, it's not going to help you to tighten stuff. So hold on to the plate up here at the top, and I'm going to put the short side in, and I'm going to give these ones we're going to make them nice and snug. So give it an extra little crank there. The next step, we're not going to tighten as much. All right, next up is the 5-to-1 cartridge. So we want that 5-to-1 planetary gear stage here. Okay, and this basically will just drop on. You're going to have to move it around a little bit. I think if you push in the middle, it helps. And what you want to do is make sure you can press it down flat. So I think it should work pretty much no matter which way this is facing. Let me see here. Oh, I had it on. Okay, I think just about whichever way it's facing is going to be okay. Let me check another couple spots. Yep, looks pretty good. Just make sure you have no gaps kind of around the outside. Make sure you squeeze that in all the way so that this seam here looks pretty consistent all the way around the motor. All right, and next up, get rid of the used bags here. We are looking for the ultraplanetary, this is the female 5 millimeter hex output V2, is what's labeled on my bag. All right, let's get into that one. And just like the big planetary that we did before, the max planetary, this stuff is pre-greased. It felt pre-greased, so I don't think we have to add anything there. All right, this one goes on the same way. So we just kind of line it up. There's the side with the hole. That's going to go down. It's going to go on top of this gear. And we just line that up and push it on and find a place where you can put it in so that, again, the seam has no cracks. And then we've got a bunch of different bolt lengths here, and we have to find the right one. So these short ones here, we're going to need all of these, but not for this step. So let me slide those off to the side. Then we've got the next shortest ones, and those are actually the ones we need for this step. Because we're only using one of the stages on the planetary, this bolt will fit all the way down through, so that's the size we need. If we were using 2 stages, we would go to the next bolt size up, and if we were using all 3 stages, we would go to the longest bolt. All right, and all we're going to do with these is there are, looking from the top, right, we have this pattern where there's 1, 2, 3, 4, 5, 6 holes. We have the pattern on the very top where there's 5 holes, and then down in these recesses, we've got 6 holes going all the way around. And those are the holes we're going to use to hold the transmission together. So find one of the recessed holes, and you can drop the bolt in there. Wait a minute. Let's pop this off and take a look. It should go. Yep, that should go. Let me try it again. Felt like it was getting stuck on something. There we go. So they should drop in pretty easily like that. I'm going to start one in all of those recessed holes. So we just keep turning it around, drop another one in, turn it to the next one, drop the bolt in, next one, drop the bolt in, last one, drop the bolt in. And again, if you have any of these that are hard or whatever, looks like taking it off and kind of putting it on or wiggling it around, realign them. And for these bolts, these 6 bolts, you're going to need not the 2 millimeter hex key anymore. You need the 2.5 millimeter hex key. And we do not want to over tighten these bolts. So we're going to just, by spinning this, we're going to take them down until they're just touching. And when we get to the point where they're just touching and you start to feel the extra feedback, we're just going to stop. And just like when we were doing the wheels, we're going to kind of do a star pattern. Just move around to the opposite side so we can pull stuff down evenly. Okay, and then we'll go across to like this one. And then the last 3. Okay, and these do not have to be super tight to hold this together. And we don't want them to be super tight because what can happen is you can kind of crush this down a little bit if you really torque down on them. And if you crush it down, the gears are going to bind up. We're going to add a lot of friction. So once you kind of get them all where you think they're good, go back around one more time and just make sure none of them are loose. Because what can happen is when you pull the gap out on one side, the other side could end up being a little bit loose. So go back around. Don't over tighten them though. And we should be in good shape on that one. Okay, and if you spin the back of the motor, you should see the front of the planetary now. This is our output, is spinning around along with it. Although spinning around a lot slower because we are using a 5-to-1 transmission, 5-to-1 planetary cartridge in there, which means I have to actually spin the motor around 5 times for this output shaft to spin around once. So we're actually slowing the motor down, which is going to give us kind of a better speed. It still spins really fast, but we're going to also get torque from that, or strength. So we're going to get 5 times as much torque, which means we'll be able to like suck up the cone and hold on to it. All right, next piece is the ultraplanetary 1/2-inch hex key adapter. Okay, and this one is going to end up sitting on top of here. You'll see that here there are only 5 holes. This side does not have a hole. That side actually has a space for a set screw, which we're not going to use. That's for the other hex shaft, so don't worry about that. This is going to get bolted on top. We're going to line up all 5 of those holes, and we're going to use our shortest bolts here to drop in to screw it all together. But here's the problem. It's really hard to get those bolts started because they hit the hex on here. So the easiest way I've found to do this is to take the adapter off, and we're going to drop all of the bolts in first. So all 5 of these bolts, we're going to drop them in. And then we'll be able to bring this down, line them all up, and sort of screw them in. We'll sort of hold this up in the air and screw them in as we go. But before we do that, I want you to check to see if you have any extra of these M3 bolts. So we're going to use 5 to attach here, but when we mount the motor to our side plate, we're going to need another 6 bolts. So if you only have the 6 that came in this bag, you're going to be short for now. And so you'll need to go out and get some more M3 bolts. But what we can do right now is if you only have the 6, we're going to put 3 of them in here so they make an equilateral triangle. And then we'll have 3 bolts left to mount this to the side plate when we get to that step. So if you're short on bolts, that's what you should do for right now, and then come back and add the extra ones in later. But I have enough bolts, so I'm going to put them all in, and I'm going to start screwing them into our output here. And you need to get all, if you can get all of them about halfway in, then they should all fit and pass around the hex shaft here. And because it's still nice and loose, I should be able to drop that one back in. No problem. Okay, now I think we can take them all down until they're close. Okay, and these ones, right, we didn't want to over-tighten the previous set, but these ones you can tighten down. They can't crush anything. We're not worried about it. We just want to make sure they stay nice and tight. So I'm going to go around now with the short side of my hex key in there and just give them an extra little tug to make sure they're all super secure. Perfect. All right. And that is it. Our motor and our planetary are fully assembled now. I'm going to put all of the hardware back in the bag, except I'm going to save these extra. the short M3 bolts that we're going to use to mount it to the side plate in the next step. All right, so let me get rid of some of this garbage. Let me bring out the pieces we need to keep going. All right, time to start working on these side plates. And let's picture kind of the way they're going to look. So they're going to be on the robot around that 1-inch box like this. And then we'll have another set on the other side. So we're going to work first on the, let's do the right side of the robot first. That is the side that has the motor attached. So right now, this is outside of the robot. This is the middle of the robot. And so that motor that we just worked on is going to attach right here. And then that means that in this plate, we need to put bearings in all of the holes. In this plate, we only need to put bearings in these 4 holes. We don't need another one for the motor. It has a bearing kind of inside it, supporting the output of the planetary. All right. And we're going to put the bearings in first. Also, the other side doesn't have bearings in all the holes. So don't do the other 2 plates yet. That side's going to be a little bit different. So all of these big holes, including this weird one, which has the motor mount pattern on it. And the idea here is that just like it's easier to manufacture and not get things mixed up if every plate is the same. So this will fit the bearing, but it will also fit the motor mount and other types of motors as well. So let's start with our bearings. We need those 1/2 inch. We're going to use hex bearings. I think also if you have 13.5 millimeter round bearings, it would fit on the hex shaft as well. But just make sure it is the stuff for the hex shaft that we're working with. And if you hold these plates up together like this, right, and the motor is coming in from the outside, we're going to tip them out like this. Okay? And so they're kind of making this shape, this V shape where they're pointing away. And in this case, right, this is the inside of this plate. So this is the inside. And this is the inside of this plate. Right? Because when they tip up, those will be on the inside, and then the other one is the outside. All right. And this is the hole that we are going to attach our motor to. Right there. All right, so now we know we're going to attach bearings here, 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 and here. Okay, so we have our bearings, and there's a couple things that you can do to try to get these to go. You can try to just push on them by hand at first and see if that's going to get you anywhere. Another thing is if you feel around the edges of these holes, if it feels like there's a lot of burrs and stuff, then we can use the deburring tool around them a little bit. Don't do a lot, though, because, again, we want bearing holes to be nice and snug. So you could go around a couple times just to knock some of those burrs off. But I think it's still going to be tight even after doing that. All right? So the next step to this is if you kind of like line it up on the hole, you can try to use the palm of your hand to push down on it. And if you can get it to start going in the hole, you'll be in good shape. So on this one, this end is not in, so I'm going to this end is much higher, so I'm going to try to push on that. And I can't get that to go right now. Nope. So what that means is we're going to have to do something else to help press that into position. We've got a lot of choices. Choice number 1 is we could use the arbor press to press down on it. You could use the vise, just like we did to press the pinion on. Or we could tap it with a mallet. The one thing, though, is we don't want to hit on this outside or on the inside part that moves on the bearing. We want to try to hit on the outside part. Or another way you can do it, so you can get a socket that fits around the outside. Or if you have something soft enough, like a piece of wood, we could line the wood up and hit it. Because the wood will give, it'll crush. The wood will crush instead of the inner race on our bearing. So let's try that, because I've got the piece of wood here, and the sockets are harder to get to. So we can try to tap on. I'm going to tap on the high side. Okay, and that is now in. It's kind of flat on the table. If you can get it that far, you can try to push it by hand the rest of the way. This is not moving. So now we have another problem, which is I need to be able to tap on this or push it farther so it goes through the rest of the way. If you do have a vise, you can sometimes close the vise so that it is close to. You want to get as close as you can to support the plate, but not touching. So then on this one, I think I could bring my wood block back up and the hammer, and I should be able to send it the rest of the way through. So that one is in now, and that one is in nice and flat. I can see there's no gaps here around the flange area. So we have one bearing that is in all the way. And I didn't mention this explicitly, but I will again. All of the bearings should be going from the inside of our plates to the outside of our plates. So we want all of the flanges on the inside. All right, so there is one in. Let's go ahead and try to get the rest of them. And it depends on who manufactured your plates. Some of yours, the holes might be tighter. Some, they might be a little looser. And that's OK. If they're a little bit tighter, that's not a bad thing because you want the bearings to be nice and secure. If they're a little looser, it's still going to work. We have ways to keep the bearings from falling out. The other thing is if you're very careful with the mallet, you can just kind of tap on the ring around it without kind of hitting the middle part. But it's safer to just use the wood block or use the socket. So that looks like it is as far as it's going to go. It's flat on the ground here. So another thing you can do if you don't have the vise is if you take a bit of scrap 1x2 that we've been making a lot of the robot out of, and all I did was I drilled a hole in it with the step bit that is big enough for the bearing to just barely fit through. And the idea now is I can line up the bearing with that hole. And so now there's room when I hit it for it to slide down inside of that hole. So if you don't have the vise, you don't have the other stuff, then this will work perfectly for you. You just have to make your own tool. All right, so that's in and flat. And once again, you can try to spin that inner bit after you hammer it and make sure it still spins nice and freely. All right, let's do the last two on this plate. We do have to move this so that the other bearing is not in the way. All right. Looks good. All right, looks good. All right, that one is all good. So this side of the plate is done, or our two plates are done. Let's do the other plate now. Same process. Oh, this one, interestingly, is just loose enough that like if I push on the high side, I can sort of wiggle it, wobble it all the way until that is in and flat. So that's good. Yep, this one too I can do by hand. So like I said, it just depends on your plate, how tight they're going to be, and whether you need to bang on it or not. With bearings, you always want to try to do the gentlest approach first, and then get more aggressive as needed. Yep, so this plate, it looks like they're all going in. We're going to do this hole. Okay, and then our last bearing is going to go in this fancy hole, right? It looks, I don't know, what's like a kind of a gear shape pattern. So this should still be able to line up and push into that hole as well. All right, so that's our first two plates done. We're going to need all of this bearing stuff again when we do the other side. So I'm just going to set it off to the side there. And now we're going to attach our motor into this spot here. And I don't think it matters too much which direction we are when we attach this. The motor itself, the motor bolts are going to go through not these outside holes. They're going to go through all of these little cutouts. Each one of those is for a bolt. So that's where we're going to attach it. And in general, like if you think about it, this is where the bar is going to go, right? Our one by one bar is going to go back this way towards the robot. So our motor wires, generally, I want pointing back in that direction because that's where the thing they're going to plug into is going to be. So I'll pick somewhere, one of the holes where they're kind of pointing back along this line of dots here. And the motor should be coming from the outside of the plate, which is the inside of the robot, but the outside of this plate. So it'll be on the side where all the bearings are poking out, not the side where the flanges are nice and flat. So we're going to come from the outside in, line up those wires a little bit. And then we'll try to screw in some of those M3 bolts. And this is where I said save 3 if you only have 6. I've got enough extra, so I'm going to put one in every hole. You definitely want to keep the first one loose. We want to get them all started again, because you can see how easily it shifts out. Since it's not a full hole, when there was only one in there, it could kind of just slide and fall completely out. So I'll get all of them started, and then we'll go around and snug them all up. All right, and a word of warning before you snug them up, these are very tiny bolts with very tiny bolt heads, and this is plastic, it's not metal. So if you really start cranking on these, they'll probably dig into those grooves and kind of make their own hole. So for these, I think you definitely don't want to use the short side. That will make it too easy to over tighten. And I'm just going to snug them all up a little bit on there. If you do start eating into the plastic and have that problem where it got over tightened, you could get little tiny washers. And the washers will help spread it out and help you grab some of the plastic that's still in place. Right, but I'll just kind of tighten it just by hand this way. I'll pull a little bit. You know, I'm not going to leave it loose, but I'm not trying to prove how strong I am while tightening these bolts. We'll save that for a later step. All right, that motor is completely attached. And you can see now when I spin the motor, that output shaft also spins. So we are in good shape there. Okay, next step on this plate, we're going to start building some standoffs. So these are going to go together. And yes, the motor is going to go into the bearing on the other side of this other plate like this. But we want more structure in between the two. So down here, we're going to have the arm. That 1x1 box coming out of the arm will be in here and be riveted on. But out here, there's nothing really holding the two sides together. And so we're going to use standoffs in between the two plates and screw in from both sides to hold on to the stuff and keep it from kind of wobbling back and forth. So these are the standoffs. They have 1032 holes in them. They're 1 inch long. I think these are a 1/4 inch in size, but really you can get bigger ones. You can get small. Well, you can't get smaller ones. I think these are the smallest they get. But you can get bigger ones, and they would still work. 5/16 or even 3/8. Let me grab the bolts for that. Okay, and this was the ones where we said it was these button head bolts, and they're about 3/8 long. I'm short on 3/8 ones, so I'll probably use a lot of 1/2 inch long ones, and that should be fine too. But we'll start with the 3/8 one that I do have. All right, and also I was saying too, if you don't have any button heads at all and you only have the regular socket heads, they're going to work for this as well. The button heads are a little bit nicer because you can see the head on the bolt. The button head is a little bit wider and bigger than the socket head. And so what that's going to do is it's going to kind of grab around this hole better, spread the forces out. But both are big enough, and they will both work. You just got to be a little bit more careful with the socket head ones. All right, and this will be a 1/8 inch Allen wrench. And OK, I'm not going to start with that 3/8 one. Now, if we look at this plate, there are a lot of holes that we want to attach stuff to. So if we come across the top of the plate in this area where there's no bearings, we're going to start with the 2 holes on the top there. So go ahead and take a 1032 bolt, and you can push them through. And then with these, you can actually just screw the standoff on by hand, and that's kind of the fastest way to get it in there and secure. And I find usually if you go ahead and try to just give the other side a little bit of a torque, it'll get tight enough that when we do the other side and the bolt is on the other side, it's not going to move. But if it's moving on you right now and you want to make sure it's nice and snug, you can grab a 1/4-inch wrench, or if I say whatever size your standoff is, put the wrench on there and tighten it. And we'll do that I'll do that on these at the end after kind of we have everything else attached. All right, the next one we're going to do is in between these two, going down sort of in a V shape. We're going to add another one down there. All right, and then I'm going all the way out to the very end of the plate. On the very end on the bottom here, there's a hole. Add another standoff there. Okay, and now I think we want this one. So if I go in a line up to this top bearing here, there's that hole right in the middle, and that should fit right in between our belts, inside our belts and everything, and should also help support, because we really don't want it to spread apart where the bearings are. That's where we want a lot of our strength. Okay, and you will notice there are 1, 2, 3 more holes. If you end up having trouble with this, if it's still not sturdy enough, or things keep falling apart, you can add more standoffs. You can get more standoffs and add them to those other holes. I think the recommendation as of when we were putting this together was to use 5 of them on each side, so that's what we're going to do for now. All right, so this will now come together, and those standoffs we can screw in from the other side, and that'll help, hold both plates together, which will make them a lot stronger as a unit. But before we do that, we've got a whole bunch more stuff that we need to put inside here that we're going to build up. Like we need gears inside here. We're going to need our timing belts and our timing belt pulleys inside here. And it's just going to be a lot easier to build that and then slide this onto everything at once than to slide this on and then try to assemble everything on the inside. So we'll set these off to the side for a second. And the next thing we're going to do is bring in the 3 long hex shafts that we made. And you're also going to need your squishy wheels. I think these came in the rookie kit of parts, so that is extra good news. But there are these wheels, and they're squishy, which I guess is how they got their name. So if you take a look at them, the middle hole is a hex shape, and that hex shape will fit onto these 1/2-inch hex shafts that we have. But you got to kind of stretch it out and help it get on. It should be a tight fit. That's what we want. And I'm going to pull this in a little bit so there's some room on the end. But each one of these shafts is going to need 10 of these. So there's 1, and then I'm just going to start sliding them down from the top here. There's 2. I think they should be about 3/4 of an inch apart. So they should be, I don't know, something like that apart. We'll be able to adjust them later, so it doesn't have to be perfect. But we got to put all 10 of these on. And each of these bags, I think, has 10 in it. So I'll empty an entire bag on this one, and then we'll just keep going. All right, I think my spacing was probably a little too tight, a little too close together. And that's okay. So I'm going to slide them a little bit farther in from that side. So we'll just kind of shift everybody down a little bit. And really, we're going to do the fine-tuning of the positioning of these after everything is together, because then we'll know for sure what the space is. Right now, our only concern is that we have enough room on the ends of the shaft to be able to put the things that we need to put on it. All right, that's 1 down. We're going to do 2 more. Going to make them look exactly the same as the first one. All right, all 3 of our long shafts are full of squishy wheels. Kind of fun to play with now. All right, we're going to take the motor plate, because it has the motor attached, and these are going to come from the same side as the motor. And if you look at it, we have 3 of these bearings kind of in a line at the bottom here, and then 1 that's sort of up higher. These are going to go into all 3 of the bottom ones. All right, the first 2 just slide in, nothing fancy. The third one, though, we have to do one thing before we slide it in, and that is we are going to use 2 different pieces here. We're going to use our, what size is that? We're going to use our hex collar, and we are going to use one of these pulleys, one of these Andy Mark pulleys. Now, we got some of our pulleys where the flange was falling off. A lot of them were good, but a few of them, it was loose and falling off. And that's kind of okay if we push it up against the bearing, right? It's probably not going to go anywhere. And actually, some of these timing belt pulleys you can use with only one flange on them or no flanges on them. But if you have some that are loose, what I would suggest doing is to just grab a little bit of super glue. All right, so let's double check where this goes first. So if I put this on, you can see this outer area will be left alone. So it's right on the side of where the teeth are going to be is where we want to add a little bit of that super glue. And I'm going to add only a little bit. I don't want to add too much because I definitely don't want it to be where the belts are and stuff. So we'll squeeze some out here and add a few drops along the way. I'll kind of aim for that middle ridge. We'll sort of wipe some on as we go. And I think that I have overdone it. We definitely don't need that much super glue to hold it because nothing's really going to make it fall off. So that looks good. Also, I do like the gel super glue because you can see it sort of sits where you leave it. It doesn't start running everywhere. But we'll take our flange on now and squeeze that on. Okay, and then I will grab a rag and we'll try to wipe off any of the excess that we can here, just so it doesn't get in the way. And then I'm going to look on the inside, too, to see if any of it is really squirting out there. And I don't really see much squirting out. Maybe a little bit here. Okay, so just a little bit should be enough. Now, we're going to leave that. We're going to put that one off on the side and let that dry. And we'll work with some of our other ones first. Okay, so our next step then is we're going to take the shaft collar and we got to loosen up those screws a little bit on it. And that shaft collar is going to slide onto this last shaft. That side's going to go towards our motor, but right now I can flip it around so it doesn't matter where it is. And then take another one of the pulleys and slide that on. And the idea is we can use this shaft collar to kind of hold the pulley in place, and it will also sort of hold that flange in place as well. All right, so now these 2 pieces are ready to slide into here. Oh, they're not quite ready. First, we have to get the belt and put the belt on. All right, so I've got my belts. There are 2 short belts that are 300 long. They're 5 millimeter or 5 millimeter timing belts. And then we've got our super long one, which is, usually it's written on there, 750. So we want one of the short ones, and the short one, you can just go ahead and put it right onto that pulley. Actually, I mean, right now we could go all the way along, so we didn't have to put it on yet, but it's better not to forget. And then we're going to slide this into our last hex shaft down here. All right, so far so good. Then the other side of this, we had that small shaft that was from the Max 90-degree gearbox. If you don't have this size shaft, then you can use the longer piece that was left over, because we are going to cut this down once we know what length we want it to be. And this is going to slide in through this one here, the top bearing, and we're going to get our timing belt on the other side, on the other pulley here, and we're going to slide that one onto that shaft. All right, perfect. Then we're going to start working some more on the inside here. And we have a few things that we're going to do. The first thing is this section here between that one that we just put in and the bottom one, we're going to take our gears, and they will slide on the top and the bottom axle here, or half-inch shaft, and that's how these two get connected together. So from this idler here, right, it powers both the front and second roller. And here's the interesting part. We need, like if we were going to try to suck a cone up in here, we need these rollers to be spinning in opposite directions. Because if they were spinning in the same direction, it wouldn't grab and pull in. We need them spinning like this so that they're grabbing stuff on the bottom and pulling it in. And that is what these gears are doing. These gears exist only to reverse the direction. So if you take a look, when we start spinning stuff, when you have two gears meshed together like this, they move in opposite directions. They rotate in opposite directions. And so by having two gears together like that, we're able to reverse the direction of our two intake shafts so that we'll be able to suck stuff in. And this back one, right, so this front section is for the cone, this back section will be for the cube, and the back one will be timed with the front one, so it will also be spinning opposite of the middle one. So that's something really cool that we've got going on here. Now, we have another issue, and that is, if I were to go ahead and say, that's great, let's go ahead and put this plate on, and you can put yours on if you want, but you don't need to, and they can be annoying to put on and take apart, so you might just want to wait until we do this for real, because there will be one more issue here that we're about to find out. But I'm just getting all of my bearings lined up. There it goes. And eventually, this is what's going to happen. We will squeeze everything together like this into the standoffs, and we'll tighten the standoffs in, and we've got our thing built. But we've got a problem, which is, if we look at these two gears, right now, there's nothing that stops them from moving backwards and forwards in here. And if one gear moves all the way to the left and the other gear moves all the way to the right, guess what? They are no longer meshed together, and they are no longer going to make sure that all of our rollers stay driven. So we want to do something inside here that helps to keep those gears lined up. So let me pop this plate back off, and the answer to that is we want to put spacers there, because if we have spacers in this area here, then the gear can't move because there will be something blocking it. And we used some of the hex spacers when we assembled the arm. We used one on each side to help keep stuff spread out the way we wanted to keep it spread out. And we could use those same spacers here. So if you bought enough of those spacers, they're very easy to use, very fast to put on, and you should be good to go. They're a little bit more expensive than our other solution, though. So depending on what you have, we'll show you another way to do this. All right, so we're back apart. So you could stack on a bunch of hex spacers there, but we're going to use our PVC pipe to make a piece that is the right length to fill up the rest of the channel. So then also it's kind of nice because it'll be one piece that's the spacer instead of we would need to stack a bunch of them in there. So what we know is when these are together, right, when they're all the way together, the gap is set by our standoffs. And our standoffs are pretty much exactly 1 inch. It's 1 inch exactly. So we need our total space on each of these shafts, the total space inside there, we want to add up to 1 inch so that there's no room for anything to move. Or technically, we want to be a little less than 1 inch because it can move a little bit, but very, very little less. So if I measure this gear, and I'm going to go from this raised boss on both sides, and if we measure the width of that gear, it's 0.495. So we can assume this is 0.5 inches, which means if I want to fill up the rest of this space, I am going to need a ½ inch spacer there. So let's make some notes. And I don't have anything to write on except for this block of wood. So right now, we need a 0.5 inch spacer, and we need one for this one and one for this one. So right now, we need 2 of those. So we'll count that up. So we need 2 right now. We'll add to it if we need more. Then this front one here, oh, wait a minute. It's not 0.5 because what I'm forgetting is there's also the flange of the bearing taking up some of that space. So let's measure the flange of the bearing. So I can come in this way and measure it as a step. So that is 0.625. You can also use this other side here. It's kind of like a little depth gauge. You got to keep it pretty straight and level, though, when you do that. So I'm getting 0.630, which is like a 1/16 of an inch. So we're going to have one flange on this side. We're going to have another flange on this side. So 2/16 of an inch is 1/8 of an inch. So actually, our 0.5 is 0.5 minus 0.125. So this is actually going to be 0.375 inches is what we need. So 3/8 of an inch there and there. OK, now the front one doesn't have anything in between it. It's just going to be the bearings. And if we have something in between the two bearings, that'll help keep the bearings from falling out. So depending on how tight the bearings were to press into your plate, some of them, I think this one will not fall out. It was very tight. But the other one might. It was a little bit loose. So for this one, we're going to just need one spacer that goes all the way across. And again, it's 1 inch, but minus the 1/8 for the flanges of the bearings. So we also need a 0.875 inch spacer. And right now, we need one of those. OK. And then I think we're going to need one more spacer. And that is on this other side here, we are going to have 2 more pulleys going on. These 2 pulleys are going to go on with this belt on them. Now, I don't really want this pulley to be in this direction, because if it goes in all the way in that direction, it can actually, you know what, the bolts spin fine, but it's harder for us to measure that gap, and we would have to put spacers on both sides. So instead, what we're going to do is we'll put one spacer here. And then on this one, this pulley should actually just kind of float to line up with it. And on this one, because the motor is bolted in, we might be worried about it for this bearing up here. But that bearing is the one that sort of scares me the least for falling out. So we're going to just add one more spacer down here. And so the question is, how wide is this pulley? This pulley is, guess what, it's 1/2 inch. So all we have to do is make not 2, but 3 3/7/5 spacers. So 1, 2, 3, 4 spacers. And then on this one, I really do suggest, if you have the actual hex spacers, to kind of put some on the inside and some on the outside to match where this one ends up. And if we need to, we can go back and add one more spacer on the inside of that one. But I think just adding some more of those hex washers on the inside could be good. All right, so in this case, I'm going to put the spacer in first. On this one, I'm going to put the gears first and then the spacers. So what we have to do is we have to head over to the saw. We're going to mark out our spacers on here. We're going to cut 3 of them at 0.375 and 1 of them at 0.875. And then we'll be ready to finish assembling this side of our intake. So we can mark it up before we go anywhere. Let's set this to 0.375. Guess we're going to make a lot of cuts, so we might as well, we'll mark it, and then we'll cut, and then we'll just kind of keep doing that. I think this side looks straighter, so I'm going to work on this side first. OK, and I am able to scratch into it. It's pretty hard to see, but my line is right around here. See, I think that hopefully is showing up, but I can definitely see it. So that's our first cut, and we're going to make 3 of them that size. Okay, and of course, cut this on whichever saw you want. Cut it with a hacksaw if you have to. I think there's even like pipe cutters that you might be able to use, but I'll use the vertical bandsaw for this one. Just adjust my guard, and yep, we'll try to cut it as straight as we can. All right, that looks pretty good. And we have a little bit of margin for error here. So I'm 0.37 on one side, and I'm 0.374 on the other side. So I would say this one's good. Let's mark another one and do it again. Okay, and the last one was not 375, but it was 0.875. All right, we'll leave the PVC over here because we are going to be cutting more of these for the other side of our intake, but right now let's finish installing the ones we got. All right, we can clean these up a little bit. Doesn't matter too much. That side's good. And if there are some burrs on the outside, if you need to, you can knock them down. They're really not going to hurt anything if you leave them in this case. All right, so our long one goes on the very front shaft. Okay. Then we have our 2 gears, and each gear gets a short one. And then not our motor, but our last shaft here will get another short one. And then finally, we're going to do the belt. And I like to kind of, if you get the belt started on both of the pulleys, then you can sort of line up and twist stuff to get that other pulley to line up. And we'll slide that in until it's hitting our spacer there. And I think that is it for this side. Let's put the outside panel on and get it tightened together. Just got to take your time lining up each one as we go. There we go, there we go. All right, there is one more thing. There's always one more thing. But remember, we were talking about having our retaining screws for this shaft here. So you've got a couple options with this one. You could leave this shaft the length that it is, and maybe that's what we'll do. Or you could cut it down until it's exactly the right size. So if I make this flat on this side, right, we could then mark on the other side here, right next to our pulley. And that's where we would go and we would cut it, and then we would have to tap the other side. So just to kind of keep things moving along, you can do that. You know how to do that if that's the way you want to do it. But remember, we get a 5-pack of these shaft collars. So let me grab another shaft collar, and if I put the shaft collar on this side, then we can screw it in from that side, and it's not going to go anywhere. All right, so I got one more shaft collar here. And all we're going to do is slide that on the inside until it is right next to, right, make it flat on this side, bring it right up until it is next to that pulley, and then we'll just tighten it down. You want to tighten this the same way we tighten everything. Get both of them close, and then you can torque down on it to hold it in place. All right, so that is good. Then from the outside, we've got our 5 standoff holes that all need screws. So let's grab some of these button heads and start screwing those in. Okay, and you might have to bend or twist on the plate a little bit to get everything lined up to push that in, but that's okay. And we'll make that one tight and keep going. I guess technically you shouldn't make it tight until they're all started. But I've found that with these 2 pieces, it usually lines up fine. You can usually get away with tightening them all the way in. Though maybe I'm running into that problem here. Yeah, let's try. Let me loosen this one up, and then And we'll try again on this one. You do want to kind of make sure that they are going straight in. I think it's just a little bit off center on, the hole is just a little bit off center. So, okay, I got to grab a 1/4-inch wrench because that's moving on me. And if I hold it with the wrench, I should be able to take this the rest of the way out again, and then we can try to reline it up. So I see, yep. Should be able to get these all started by hand too, so if you are running into that issue. Okay. And that one's good. Let's get our other two up here on the front started. Maybe we'll try to start these ones by hand if we can. Yeah, that one's a little tight going through the plastic, so. That one's looking good. And then we got one more down here in the very front. And that one lines up very nicely. Okay, then we can just go back through and just go ahead and tighten those down. If the hex in the middle is shifting on you at this point, you can use the 1/4-inch wrench, just like we had to do on that one. It's getting nice and tight. That one got nice and tight. All right. Then the next thing we can do is all of these shafts are tapped. And this one doesn't matter. The motor one doesn't matter. But the other ones, we are going to tighten in a 1032 bolt. And this time, we need to use a washer to help hold the shaft in, just like we did on the jack screw and the upper arm pivots. So let me grab some washers for that. And we'll drop them on and get them started here. And this one. Wait, I meant 4 of them because we need this one too. There it is. And you can see on this one, I pushed it in a little bit farther than I meant to. So I'll go ahead and loosen this up, this shaft collar on the inside. I'm going to loosen that back up, and I'm going to tighten that in first, and then I'll do the shaft collar second. All right, let's go ahead and get all of these tightened in. And one thing that's really nice is everything we're doing on the outside of this plate, it's all the same tool. So as long as you have a 1/8 inch hex key, you can kind of disassemble the whole side of this at once. Okay. And our last one. All right, then, now that we're set here, I'm going to pull or push all of these shafts through until they are on that washer, so they're all the way flush. Okay, and that is one side just about done. There's the last two things. We've got this shaft collar up here. I'm going to slide it in until it's touching that pulley, and then we'll go ahead and tighten that shaft collar down. And then we also have one down here on the front that we're going to use as well. And these also should hopefully help keep if those flanges start coming loose on our pulleys. Hopefully these will help with that as well. So go ahead and tighten this one down. All right, so now that whole side of our intake is done. We now are going to move this out of the way, grab our other two plates, and build the other side of the intake. All right, so now let's picture these two plates. They're going to be going like this down here. And nothing goes in the top holes on this one, and nothing goes in the other set of top holes on this one. So we're really just looking at, if we bring these together, again, kind of into that point, we are looking at these bottom three holes that go in a line. Those all need bearings. This one doesn't need anything. This one doesn't need anything. That one doesn't need anything. So same process before. We're going to try to get the bearings into the holes. And again, I will mark, just so we don't forget, this is the inside here of this plate, and this is the inside of this one. And the bearings need to go from the inside so that the flange stays on the inside. All right, let's see if we can get this one to go by hand first. Yep, no problem. So this plate was a lot like the second plate we did over there. A little bit of a push to get it started, but then kind of able to work it the rest of the way in. Let's see how this one goes. Okay, that one is too tight. That one's going to need some banging. Yep, this plate looks like it's tight like the first one. So let me bring back my multi-tool here. It is both a pad of paper and a bearing hitting device. That is flush all the way around. Bearing still spins nice and freely. Next one. That one popped out. Let's try again. Gonna actually, on this hole, just because it seems like it didn't want to start, I'm gonna go ahead and deburr one time around just to make sure there's nothing on the top that's making it hard to get started. Okay. Let's give it a shot now. Make sure I'm lined up on my hole there. All right, check around the side, no gaps. Bearing still nice and smooth. Last one. It's very close to wanting to go in, but let's hit this one with the deburring tool too. It also kind of chamfers the edge a little bit, so we got a little bit of a guide to help get it to get started, which I think helps a lot. I think if I had to guess, there was some extra bits of plastic on the inside that I've knocked off now, and so it should go in a little bit smoother. All right. Lined up. Good, no gaps, bearing spins freely, excellent. Let's get back to our assembly here. Now, again, they're going to face each other, right? The flanges of the bearings are going to face each other. So let's take this plate, which is going to be our inside plate here. So in this case, it's the bit of the bearing that's sticking through, not the flange side that's nice and flat. And let's get that lined up on these 3 shafts here. And we're just going to kind of slide that in. There is no specific spot that we want to put this, but we're going to push it in far enough that we have at least an inch, right, of space, plus the thickness of the bearing on the outside to be able to get everything to fit. All right. Then, on the middle one, we are not adding anything. And on the front and back one, we're going to be using our last 2 Andy Mark timing belt pulleys. The glue is set on this one. It does not feel like it's going to fall off. All right, so we'll slide that all the way in on one, slide this all the way in on the other, except now it's going to be really hard to put this timing belt on, so I'll probably slide them back out to the edges here. And we'll get this timing belt started. And then we will line it up, if we can. There we go. All right, and those will slide in to the inside of our plates here. And you can see this nicely goes over this one. And really, that is everything that goes in on this side. So we could slide this on, except we know we're going to need some more spacers to fill those gaps. And it's going to be the same size spacers we had on the other side. So it looks like we need these 2 to be 3/8 long, 0.375, and then this middle one should be 0.875. So let's go ahead and cut our last 3 spacers, and then we can add our standoffs and put everything together. All right, my calipers from the last time we were over here still set at 0.875. So let's go ahead and get a line going so I can see what's happening. And we'll scratch it in, scribe it in. All right, and let's get this one cut. And then we're just going to do 2 more at 0.375. All right, so the 2 with the pulleys get our 3/8" spacers, and then the one with nothing gets the 875" long spacer. And then let's go ahead and add our standoffs. So again, there are a lot of spots where you can put standoffs. You can use pretty much whichever holes you want, but we are going to start with looking on the outside here. We have these 2 holes that are up on the top of the plate in the middle. We definitely want one on each of those. Okay, and then remember, right in between those, we're going down to make a V shape. We're going to get that plate on the bottom down there, or that hole on the bottom. Okay, then the next one we know we want is all the way to the very edge, the very front edge of the whole thing. All right, and then it looks to me like these 2 holes on the front would be nice to use, but they look a little close to the belt, so I'm not going to put one in either of those 2 holes. You can check yours, and if it looks like it's going to clear and not hit anything, go ahead and use it. But I definitely don't want the belt to be rubbing on stuff like that. So in order to support kind of this front section as much as possible, I'm going to use, down here at the bottom of our V, there's one more hole forward, and I'm going to use that hole just to try to get as much support forward towards those bearings as possible. And you could, if you wanted to, you could drill another set of holes. You just got to make sure that they line up. but I think this one should be pretty good. All right, then outside plate is going to line up. We're just going to get that to go onto all of these different 1/2-inch shaft pieces here. We'll slide that in till it's just about touching on our standoffs, and then we're going to go ahead and tighten in bolts from the other side into those standoffs. Remember, we're not going to tighten it, and should be pretty easy to go if you can get everything bent and twisted in the right direction. This one is, it's the hole in the plate is a little bit tight, so this one will go ahead and flip it over to go a little easier. All right, let's get this front one here. That one is trying real hard not to line up for me. So I'll push on it until it does. There we go. And then we got one more right here. And I'm having to really kind of twist the plate a little bit to get those standoffs to line up nicely. So if yours doesn't just go in super easily, just push or push down or pull down on the spacers, the standoffs until you get them lined up enough to go. Okay, and we'll just go through and tighten all of these up. All right, and then the last thing we're going to do is, once again, these are all tapped holes. We are going to put washers and another bolt into each of them. There it goes. All right, and I'm short one washer, so let me get these two tight, and then I'm going to go grab that last washer. All right, got my last washer. I miscounted, had to go find one more. And this one will go into our front shaft here. Perfect, okay. And I'm going to slide these out now until they're hitting the washers, because that should be pretty close to the position we want them to be when we attach them to the robot. All right, but before we attach it to the robot, there is one more piece we have to make. There is something called the intake plastic. So there's a piece here that kind of makes a little hoop. And the idea behind that hoop is when you bring the cube in, right now, there's nothing that stops the cube from going through and falling out inside the robot. So we need some kind of backstop here. So let me clear this off. It's going to be another gigantic sheet of material. So we'll clear this off, bring that sheet in, and cut the size that we need. All right, so this is the plastic that we're making it out of. I don't know, it says Polywall utility panel on it. But it feels pretty strong, and it's very flexible, which is what we need for this step. So let me kind of fish this under here, and I'm just going to clamp it down so we can mark it without it running away from us here. Now, for this one, unlike the polycarb that we did before, this one you could totally do on the ground because we are not going to need to score this and snap it with a razor blade. You could probably still cut it with a razor blade, but we do not need to do it that way. All right, so the first thing we're going to do is this panel is going to be, I think it's going to be 18 by 5.5. So we're going to go ahead and measure a 5.5 section in from the end here. And we'll just get a couple marks at 5.5. And I'm not really going to use the T-square part of this because the T needs enough material to sort of grab into, to square up with. So instead, I've got 2 marks that should both be 5.5 inches. So if I take just the giant ruler, and remember, if you don't have a ruler, just get a piece of metal, piece of 1x1 box or whatever you've got around. And we're just going to line this up on those 2 marks. And if this is a little wider or a little narrower, it's going to be okay. This is not one of those super precise pieces. And we'll just go ahead and draw a line all the way along our piece here. Okay, and there are a few different ways you can cut this. Of course, I think you could cut it with the razor blade. Just make sure you have something underneath it, because in this case, you'll actually cut all the way through. You won't score and snap it. I think it'll cut with a pair of scissors. So let's start with that and see how it goes. Yeah, that is cutting. It's tough. It's a little tough, but it is cutting. I got to use kind of just the back side of the scissors. So if you're going to use the scissors, I do recommend that we also mark the stopping point, because you don't want to cut all of the extra if you don't have to. So this is going to be by 18. Right, so we know we need to cut till about here. That's 18 and 18. And we can once again connect those lines up and draw a line through them. So that's the section that we actually need. If you have them, I've got some shears. Actually, let me use the red ones. So these are tin snips, and they cut just a little bit easier. It's a little bit less work for my hand. Yeah, when I said the red ones, I meant the green ones. So these shears also, or these tin snips also, go in such a way that you can bend one of the pieces kind of up out of the way as you cut. And in this case, I think bending that up and away from me is going to be fine. So we'll go ahead and just cut our way down. Just keep going till we get to our mark here. All right, and I'll go a little bit past the mark, and then I'll turn around, and we will now make the cut this direction. All right, that's the piece we need. Now, let me clean this edge off a little bit. I think I like the deburring tool for this. Works pretty well. Just get some of those chunks where you can see the scissor work. There we go. All right, so that is the piece we're going to attach now to our intake. So let me get rid of this big sheet, bring the intake back, we'll get this attached, and then I think it's ready to go on the robot. All right, so this piece that we just cut out is going to go from, actually we're going to attach it to the same bolts over here that our standoffs are connected to. And it's going to go from here all the way across to the other side where we'll bolt it in place. But we want to make sure that when we drill those holes, they are lined up about a ½ an inch up on this piece. So what we're going to do here is on each side of this, we're going to make a mark that goes up about ½ an inch. So I'll make a couple marks just so it's easy. Same thing on the other side here. All right, and then we'll go ahead and draw that line on. And we'll do the same thing on the other side. Okay, so those lines are what we want to line up with on these bolts to be able to put it together. So our next step, though, is we've got to take these standoffs out. So after all that work, we're going to remove, and this is the top two standoffs of the V, the ones on the very top of our plates. And the reason why, we're going to drill from the outside in so that we can make sure the holes line up. But unfortunately, that means we need both bolts and the standoff out. I think we should be able to, there's enough room for us to grab the standoff, though, and slide it back in to line it up later. So we won't have to take the entire outside plates off. That would be much more work. And do this side too. Because I think we might as well clamp up both sides. I always like to clamp the piece completely where it's going to go, because then we know it fits, we know it's working. Right, let's get these outside ones out. That one got very tight. All right, there we go. And then the last one. All right, so once again, we'll start on this side. What I'm going to try to do is line up that line so it's on our holes. And then I'm just going to try to make it so it's even on both sides. You could measure from both sides in and make a mark if you wanted to. I think it's going to be accurate enough this way. Because again, the position of this, as long as it stops the cube from falling through, the position is just fine. So let's get this lined up, and we'll try to get this first clamp on, which is always the hardest clamp. Okay. That looks about even on both sides, and that looks like the line is pretty close to where we want it to be. Maybe slightly low. Okay, that looks good. Let's get the other side. Right about there. And we'll double check now. Yeah, that looks pretty even on both sides, pretty good to the line. Spin this around. We are going to do the same thing now on the other side. And it is going to be a little bit tight of a pull here. And that is to be expected. It's about centered. that side looks good. Let's just push this side down a touch. All right, that looks good as well. Okay, now we're going to drill. And all I'm going to do is start on the outside of the outside plate, and we're just going to go through the holes that are already there, and then drill through that plastic panel. And it should take very little. All right, just cleaning it off a little bit. There was some junk stuck there. Then I'm going to hold this standoff in place and start it from the outside here. Screw it back in. Let's do the other one next to it. And if we leave the clamps on, it'll be a little harder to reach, but the piece won't move. So I think that's what we're going to try to do. Let me see if I flip this over, maybe we can see what is going on. Okay, and I'm just going to screw this one into the hole we just made. If you have a lot of plastic coming out of that hole, you can always clean it up, deburr it, or file it. Or really, in this case, I was able to just kind of grab onto it and tear it out of the way. All right, and that is going. Okay, and I made a mistake. We can't put this other one back in because we didn't drill the hole yet. So let's take that one back out. All right, now we'll drill the second hole on this side. And now the standoff goes in for real. Okay, and then this clamp can come off, but the other one we won't take off until we get the bolt in. So let's get that bolt in. That feels crooked. Definitely want to make sure it goes in nice and clean. All right, there we go. Okay. Take the other clamp off of this side. And now we're doing the same thing on the other side here. So I'm going to go ahead and drill the holes. And then we'll flip it over to tighten in the, oh, hold on. Before we flip it over, let's start with the outside one, because that holds it in place for us. All right, then flip it over. Let's get that inside bolt in. That did not go in the way I wanted it to, so we'll back it out and try again. Let's try one more time. and now just check again before I drill, make sure it's still on the line. Looks like nothing moved, so let's go ahead and pop the last hole in. And we'll start our standoff again from the outside here. And then flip it over, and let's get that bolt on the inside. All right, at this point, we can pop off the clamps here. And before we put this on the robot, just to make sure that this is the right size and shape for this piece, let me grab a cube. And let's see what happens if we try to pass the cube in. So if we try to suck the cube in, these will spin this way. It grabs the cube, it pulls it in, and that is totally in a good spot to stop it while we can still grab the cube to spit it back out. All right, so we're happy with the cube. I guess let's check a cone too. We got some cones here. All right, so then for the cone one, we'll try to kind of suck it in this way. Yep, and that looks good. Like we're grabbing the cone all the way in, and we can spit it out. So I'm pretty convinced this is in the right spot. Everything is together the way we want it to be. So next step, we're going to bring the robot back in. We're going to attach this to the robot. Once this is attached to the robot, I think we are done for this video. So we're almost there. Robot's here. Plastic is on top, right? So we swung it forward. Now that this plastic is on, we actually can't swing it the wrong way. We've got our two sides here. And the way it should look is the motor should be on the right-hand side of the robot like we talked about. And these are just going to go on the sides of these two 1x1 areas. And see how it's kind of going out and then scooping up. So make sure it's going out and scooping up. If not, you might have attached something backwards. Then, if we look very closely on the side of these plates, you can see there is a row of holes on the side. And then there's actually these two little slits that I think are cut in them. And that is just sort of help align where this box is going to go. But because we pre-drilled some of the holes, now obviously not all the holes are drilled, but enough of the holes are drilled that we should be able to just stick some rivets in those holes. So I think the very first one can get a rivet. And the idea is if we can get these holes to line up here, am I seeing the actual hole, or am I seeing a reflection that's not in the place where I think it is? All right, there is one. All right, and then we can go back and try to grab the back hole as well. Okay, and this goes a lot easier if you have a couple people trying to like hold and line this stuff up so it ends up in the places you want it to go. Let me do some on this side as well. Essentially, we want to kind of get the rivets into a lot of these spots, and then we can just go through and pop them all once we know kind of everything is where we want it to be and lined up. Let's try to get that first hole in. There we go. All right, and I'll try to do the two on the inside here too. And the two on the outside here. And at this point, that is, we are lined up to our previous marks. Everything should be as square as it can be. So let's pop these rivets and then add the rest. Okay, so with just those 4 rivets in, let's kind of take a look at the robot, make sure everything looks good. So one of the things we're going to try to do here, let me spin it around a little bit, is we want to make sure that this will come back in and store inside the robot. And it does. We have one small problem that we're going to have to deal with. But that is moving in and it is moving out, and that is the way that it should be looking. All right, so our one problem that we're going to have to deal with is, and we're going to finish attaching it. It's not going to stop us from attaching it, but the shaft coming off of this motor, when it comes in, it is really close to hitting this box. It sort of drags along that box as it goes in and out. So we're probably going to end up cutting some of that away just to get that clearance back. But everything looks good for us to finish these rivets up here. So let's bring this back up on the table. And let's walk around. Let's pop all the rivets that we can get to. So I think we drilled 4 holes. Okay. And 2 more on the inside here. All right, perfect. This is actually probably enough rivets to hold everything and be strong enough, but we've got 3 more holes in every spot, so I'm going to drill them out and rivet the rest of the holes. Now, in this case, these plates are already super secured. They're not moving anywhere, so you can drill all 3 of the holes and then rivet all 3 of the holes. Of course, if you have 2 people and you drill a hole and the next person is there ready with the rivet, then go ahead and do it one at a time, but since it's just me, I'm going to drill 3, then rivet 3, drill 3, rivet 3, and we'll have the thing fully attached. When you're doing this inside one where the motor wires are, be very, very careful not to hit the motor wires with the drill. All right, finally, all the rivets are in place. So let's clean up our mess for this, and then we'll deal with this motor shaft, and then we'll be all set. Okay, so our last problem is that shaft that's sticking out a little bit too far. On my robot, it's just barely scraping as it goes in and out. I probably could leave it or just file it for a little bit, but it's always better to have a bit more clearance because if anything loosens up over the season, it might swing a little bit more one direction or a little bit more the other direction. So you got a couple options. If you wanted to, you could take this whole side plate off. Then you could disassemble the motor, and then you could just have that one shaft here that you could then cut down. I don't really want to do all of that. I think we can cut it while it's on the robot. So while it's on the robot, any portable saw you have is going to be okay. I think if you go this way, you can get a hacksaw pretty close, and we don't have to be flush with the bearing. We want maybe you can leave a little bit of a gap, but there is room here to get in there and do the hacksaw. I'm going to try to take the fast way out. Let's see if the angle grinder will get in there. Okay, not really. So you know what? I guess we're going to hacksaw. All right, so unfortunately, though, yeah, we can do it left-handed. That should be fine. Get ourselves some clearance here. Or it's going to hit this, so it really needs to be facing this way. Okay, so we're going to have to swing around to this side of the robot. And we'll just kind of cut, I don't know, most of that shaft off. I'm going to leave myself about 1/8 of an inch. And once again, with the hacksaw, we just need to get ourselves a groove in the spot we care about. Okay, and then we're going to start going sort of as far as we can. It'll also help if you hold the motor or hold the rollers so that the axle doesn't spin on you while you're doing this. I'm trying to keep it also from cutting too close, so I'm trying to make sure it stays straight. All right, let's file that off so it's nice and clean and we have no sharp ends there. And I'm kind of spinning the motor just to get all the way around all the edges. And we'll kind of try to blow off the dust so it doesn't get too much into the bearing. All right, and there we go. That is much shorter. Let's put these tools away. We'll test it, and then I think we're good. All right, so now with the cut down shaft, let's see if that solves our problem. Kind of bring this back, get it re-engaged. Again, watching those pinch points. Bring this around so we can hopefully see it here. All right, so it was this shaft, and as we pull this in now, oh, I got so much room. That's beautiful. So that problem is solved. All right, we have successfully built the intake, attached it to the robot, handled all of our interference issues. We are good to go with this section of the robot. So we're done for this video. We'll see you in the next one. And as always, special thanks to Argosy and Everybot.